In this third video that goes with the double angle identity worksheet, right here, double angle identities notes, we're going to be looking at example 5. So example 5 is back to solving equations, which you just did in the last unit. You just did it on the test. So notice that in this one we're going to solve for x between 0 and 2 pi. Remember, x is just an angle, so we could use theta. We didn't, all right, which is also fine. So, but if you think about theta being between 0 and 2 pi, here's where angle would be, the angle would be 0. A full rotation would be 2 pi, and so it's really any angle in there, but only in one rotation. All right, so what we want to do for this problem, you'll notice that both of them involve a double angle identity. So we want to replace that with something, probably, in order to solve this. So with sine of 2x, we only have one choice, right? Sine of 2x is 2 sine x cosine x. So that's what we're going to do here, is replace that with 2 sine x cosine x minus cosine x is equal to 0. So remember, this equaling this, that's a trig identity. So now this problem is just like other problems that you've done. You have two terms, so term 1, term 2 equals 0. So I'm going to factor out the cosine of x from the term. So I get 2 sine x minus 1 equals 0. And so now if I'm multiplying two things together and getting 0 for an answer, then one of those two things has to be 0. So that means cosine of x has to equal 0, or 2 sine x minus 1 has to equal 0. So this, of course, is cosine of x is 0, or, so on this one, I'm going to add 1 to both sides and then divide by 2. So sine x turns out to be 1/2. All right, but now we need the angles, right? That's the whole idea, was to solve for x. So that means that x is going to be equal to, so if you think about the unit circle, where's the cosine 0? Cosine is 0 on the positive and the, no, I'm sorry, cosine is the x-coordinate. Cosine is 0 here and here, because this is the point 0, 1, and 0, -1. So cosine of 0 is when x is equal to pi over 2, or 3 pi over 2. And then the sine x is 1/2, so that's going to be in this quadrant or this quadrant. Remember, all students, so that sine is positive up here and here. And so that's going to be x is also equal to pi over 6 or 5 pi over 6. Okay, so those are your 4 answers. And anyway, those are your 4 answers for that one. Okay, for 5b, we have a double angle for cosine. And remember, the thing that's sort of bad about that is that we have 3 choices. But it also is sort of good because it gives us 3 choices. It gives us some flexibility. So you'll notice in this problem that we have cosine of 2x plus sine x. So wouldn't it be nice if this whole formula was in terms of sine x instead of having the cosine of 2x in it? Well, remember, we have a version of that formula back here. Here's cosine of 2 theta that only has sines in it. So 1 minus 2 sine squared theta. So that's what we're going to use here. So I'm going to write this as 1 minus 2 sine squared x plus sine x is equal to 0. And then again, it's just a matter of doing the algebra to solve this. So I get -2 sine squared x plus sine x plus 1 is equal to 0. I might like to not have the negative leading coefficient, so I'm going to multiply everything, both sides, by -1. And so that gives me 2 sine squared x minus sine x minus 1 equals 0. And then we're going to factor that, and I'm not going to take you through the factoring. If you need practice factoring, come see me. So this is going to factor as 2 sine x plus 1. You might stop, if you haven't already, stop the video and see if you can factor it. And then we're going to have sine x minus 1. And notice that if I multiply the first, I get 2 sine squared x, that's that. The outers give me 2 sine x, the inner, or -2 sine x. The outers give me 1 sine x, so that adds up to negative sine x. And then the last give me -1. So we're good. So now, since I'm multiplying two things together and getting 0 for an answer, one of these two things has to be 0. So either 2 sine x plus 1 is equal to 0, or sine x minus 1 is equal to 0. This means sine x is equal to 1. And then over here, this means sine x is equal to -1/2. So now, again, if you go to the unit circle, sine is negative in these two quadrants, and so we're going to end up with x is equal to 7 pi over 6, or 11 pi over 6. And then over here, the only place where the sine is 1 is at pi over 2. So these are your 4 solutions for that one.